Alright, so I'm going to start by creating a new design. And in this new design, the thing I want to do is create what we call a form feature. So this is basically a super feature inside of Fusion that allows me to start from a sort of a primitive shape. In this case, I'm going to use a block. So I'll start by sketching a rectangle to define the profile of the block, and this is going to represent the block of wood essentially to get my size right. So I'm typing in 2.75 inches by 7 inches as the base size. And you'll see I get this rounded shape, and I'm going to punch in a height of specifically 3 inches to get started. And now this is based on what we call T-splines, and you'll see now if I turn on shaded edges, you can see essentially the patches that make up this surface, which is a little different if you've used other surface modeling. This is like T-splines based. So I have a lot more power here. I can do, right now I'm going to show symmetry. So to define symmetry, you just click on two opposing faces and you'll see that green line represents symmetry in this model. And now what I'm going to do is I'm using the crease command. So with crease, I can select edges that I don't want to be rounded. So here I'm selecting these edges, and you'll see that I only have to select them on one side of the geometry as it's mirrored to the other side. So now I've got basically a hard edge on the bottom, and now I want to start editing things. So I click on Edit Form, and now I can grab either edges, vertices, or faces, and you see I grab this edge, I can start dragging it around, up and down. I can grab edges in the back. I can grab more than one edge at a time, and I'll just drag these down. And while it might not look like it, this is the beginning of creating the shape that I want to use for my car. So if I want to be able to refine the shape more, what I need to do is insert an edge. So what I do is I make sure you double click. So double click gives you the whole loop, and then I can say I want to create two new edges essentially in this model. So now you can see by having more edges and faces, that's how you create the refinement in your shape. And what you really want to do is you want to start with as simple a shape as possible with the fewest number of edges, and then continue to refine more and more in areas that you want more detail. It makes the whole process a lot easier to work with and a lot smoother. So you can see here I'm just grabbing different edges and faces, and I'm starting to just sort of sculpt them into the general shape that I want. I'll also take a little bit of time to even just smooth out some of these internal lines to kind of get things going. You can see the basic shape of a car already starting to form. So again, I'm going to probably want some more definition in here. Again, remember, double click on one edge will get you the entire loop, which is what we want here. We want to insert an entire loop to both sides. And again, by inserting it to just one side of the geometry, that will be mirrored across. That green line is representing our symmetry plane. And I can grab a point and then see if I drag the point on one side of the symmetry line, it's represented on both sides. If I grab something just on the line of symmetry, of course, it just moves that one point. And you can see I'm starting to create those kind of the bulges in the back that are going to represent the fins, essentially. You know, probably not quite as good as some of the models that I saw in the comments on this thread, but still looks pretty good once I get done. So again, I can grab points, I can grab edges, and I'm just going to start dragging these around. You can see if I grab the whole edge, I'm actually editing the overall shape of the base. I'm still keeping it flat against the bottom, but I've now like kind of pinched it in, and I've got a little bit different shape to the bottom, but still maintaining the flat surface again at the actual base. So let's go ahead and insert another set of edges. And if you want to move it to the other side, just grab that little blue handle and then drag it. So again, now I can put just this one, by having this other set of edge, I now have more refinement, and again I can start doing things like, you know, if you grab the whole loop, again by double clicking. So again, watch this, I'll double click, grab the whole loop, and now I can edit that, or I can just grab specific edges that I want and move those around. So you can see it's just really all about trial and error. You just start moving edges and points until the geometry starts to evolve into the shape that you want. Besides inserting edges, another thing that you might want to do to break the geometry down into smaller pieces is called subdividing. So if you've ever heard of sub-D modeling, this is the kind of the root of that. So I can pick multiple faces by holding down Command on Mac or Control on Windows. And you'll see now what I've done is I've taken each of those four-sided faces and broken it up into four pieces itself. Now if I take these edges, I've got a lot more local refinement. So it's really all about like learning how these surfaces behave and just trial and error really. It just start subdividing things, start breaking it apart, grab a couple edges, move them around. Another thing you can do is if you hold down the Alt key, so I'm going to pick two faces, hold down the Alt key, and then when I drag, I'm actually going to be adding geometry. So instead of just dragging the faces, what I've actually done there is I've actually extruded the faces out, and that's how I can end up like creating that little surface feature to sort of represent the boss and the hood. So you see what I did is I actually like, again, that's holding down the Alt key. You can drag out surfaces to create new extrusions. So again, here I'm going to go to the back of the car and subdivide these two faces to give myself a little bit more local refinement. And that's where I can start now kind of tweaking these edges and moving them around. You can start to see like the definition of these rear fins a little bit more. So again, just sort of move things around. And again, it's just really a trial and error process. It's like just grab faces, drag them, move them, and that's basically it. You know, I'm just kind of going to fast forward to the end of this, but I mean, everything that I did to create this car is no different than what I just showed you. I basically just kept subdividing and dragging the edges around until I got the shape that I wanted. You know, all in all, it probably took me about 45 minutes or so to get to this final shape, and I just felt like it was a little too much to just keep showing the same thing over and over again. But it's really all up to you. You know, I just kind of experimented a lot, getting these faces just how I want them to be. And I just recommend you just keep trying. Of course, I'll make this model available so you can have something to take a look at. Once I'm happy with the model, what you're going to do is go ahead and click Finish Form. And you'll see at the bottom of the interface, this actually creates a form feature. If you ever want to go back, you can select this form feature, right click on it, say Edit. You'll be back, you'll see the faces, you can go ahead and make changes to it like you did before. And again, Finish Form exits the command, and then you're back in the Fusion interface. If you wanted to add more features like traditional CAD features like cuts, extrudes, holes, etc., you'll find all those features here in the drop downs. Okay, so at this point I realized actually that I've been designing this with the wrong size to begin with. So I actually need to scale this down a little bit to fit into the size Pinewood blocks that I bought. So this is actually really easy. I can just come up here, select the scale tool, and I'll pick my entire model. And I'm going to say I want to do non-uniform. I need to actually bring this down a little bit. So I already did a little bit of math and figured out that I need to go 0.636 in the Z and 0.625 in the Y. And that actually will now fit inside of the Pinewood blocks that I got at the hobby shop. Once you're ready to start creating the CAM toolpaths for this now, what you're going to do is click over on this far left side. You'll see under this drop down, Model, Patch, Render, Animation, and then CAM. So I'm going to click on CAM, and that's going to bring me into my CAM workspace. Okay, the first thing that you need to do in CAM is to create a setup. A setup is like a folder basically that will contain a number of operations, typically for like say one side of machining, or what I really like with the X-Carve and Shapeoko is to do one setup for each tool I'm going to use. That way I can post out all the operations for one tool, run that, do the tool change, run a new set of G-codes. So here I'll create a new setup. And this is going to be, I'm going to use a flat end mill and a ball end mill to machine this. So this will be the setup for my flat end mill. And what we want to do is we want to set up where we want the work 0 to be. So what's nice with CNC routers is to actually set your work 0 down here. So if you're used to traditional machining, you would probably put it right here because this would be in a vise or something like that. But when we're just going to mount the work directly to the work surface so that I can just zero right off of the work surface, and it's going to make things a lot easier when it comes time to do the tool change later because we won't have this surface anymore. So I'm going to set work 0 to be here, under model, you don't have to do this, but it just sometimes it's nice to just specify which model. If you have lots of parts in an assembly, you're going to be machining for this operation. And then under stock, we'll set the exact size of standard Pinewood derby block, and that is how you go about it. Okay, so now what we want to do is we want to define our first machining operation. So in this case, I'm going to use pocket clearing. So under the 3D drop down, we've got pocket clearing, and this is basically just going to machine out all the material in there. And I'm going to first select a tool. So in this case, we'll say I've got a flat end mill. Choose one that's I've got already kind of defined in here with an 1/8 inch flat end mill. We can give it some speeds here, so you can kind of dial this in based on chip size that you want, or what we can just hard code a number in here. So I'll say I want to do about 35 inches per minute. We can use that for our lead in, lead out, and for ramping, just to make it simple. I'll just put that number in for all of them. Geometry, well, we can just say we don't really want a bounding box. We're just going to remove all the material from the stock. Heights, this is just setting your retract height and your cutting depths. Here in passes, we can say that we want to do is how much stock do we want to leave. So we're going to do a finishing operation later, and so I'm going to leave about 40 thousandths of stock all the way around the model. And then we can also set our maximum step down. So in this case, I'm going to use a step down of 40 thousandths as well. Depending on your materials and your cutter and what router you're using, you can change these values. And that's it. Let's hit OK, and we'll see it calculate, and here is our result. So now we can get a preview of the tool path as it's going to cut this piece. Okay, so now I want to duplicate this to use another tool. I'm going to select this. I can right click and say copy, and then right click on operations and hit paste. So now I've got the same setup. I'm going to rename this one to ball, and we'll call this one flat. And then here I can delete the pocket from the second setup. So here in ball, I want to create my finishing passes. So I'm going to do 2 just so you can get a sense of it. The first one I'm going to do is contour. So under 3D, I'm going to select contour, and I will choose my tool again. So coming in here, I can select a ball end mill, and I will select this one with an 1/8 inch shank, and again give it some speeds. So we'll do 35. In a future video, I'll show you guys how to set up this so that it's all automatic. Right now I haven't done that yet with the tool library. And really, that's about all you have to do. The rest of this stuff is just defining some retract heights, passes. Again, I'm just going to go with pretty much all the defaults here and get a pretty nice result. You can kind of go in there and really start messing around with things to get a sense of what some of the different functions do by just previewing the tool paths here. But this should give me a really nice overall kind of spiral that's going to work its way down the model. And then I'm going to come in here and add another tool path called parallel to just finish it up. And again, I'll use the same ball end mill with the same speeds. And everything else is will take the default, and this will come in and kind of finalize it in the other direction. So is it really necessary to do both of these? You can see here actually I messed up and I put this in the wrong one. I can just drag from one to the other, and you'll see this little red exclamation point. This is good. If you ever see this, all you have to do is right click, hit generate toolpaths. That'll happen if you've changed the geometry and it needs to regenerate. And now I've got these two finishing passes with my ball and the original pocket with the flat. Okay, one of the really nice things you can do here in Fusion 360 is to simulate the tool paths. So I could either select one tool path, I could select one setup folder, or I could select the entire tree by selecting operations, and then I'll click on simulate under actions, and here I can see the entire set of tool paths, or I can turn that off, or what's really nice is to turn on stock, and I can kind of get a visual of what is remaining. So here I can come in, press play, and I'll get a nice little simulation of what's going to happen. You can turn the speed up and just kind of watch this thing as it goes really, really fast. And then you can slow down a little bit for the contour and then watch it kind of finish it off. So when you come in here and you're ready to post this stuff out, it's really nice is that I could take these, for example, I kind of want these to be in a different order, so I can just grab this and move it above. So this order here in the setup will determine the order that these operations will be performed. And then when I'm ready to post this out, so the reason I like to separate by tool is specifically for the Shapeoko. Obviously, if you had a different type of machine, it might be easier to do tool changes midstream. If you're comfortable with doing tool changes in the middle of an operation by adding in some other G code or whatever, you could do all of these in one setup and post it all out at once. I found so far using it, it's easier to kind of have two different programs to run through Universal G-Code Sender for each tool between tool changes. So here I'm going to say that I want to post-process the flat, and here under post-processor you can scroll down and find Gerbil. So we'll select that and we'll say OK. I'll save this one as call this one Pinecar-flat. You'll see after you do that, it brings up the G code in an editor. So here's where you could go through and make any changes you want. For example, when I was first starting to do this, I was removing the G28 lines, which is to go to the home position, because I hadn't really set it up yet for a home. So you could remove G28 lines here and at the end. If you haven't set up a G28 position on the Shapeoko using G28.1, you definitely want to before you run this code. If you haven't done that or don't want to do that, I would recommend then removing these G28 lines, and you can quickly do that by Control F, find, and then just search for G28 or any other specific codes that you didn't want, delete them, whatever you want to do. Back in Fusion, and I will now select the ball setup, and we'll go ahead and post-process this. Again, you can either get that from up here or from the right click, and again Gerbil, and we'll go ahead and post this one out. We'll call this one Pinecar-ball. And again, it brings it up in the editor if you want to make any changes to the G code, review some of the startup, or whatever you want to do. So one thing that I need to point out is that when you save these files, Universal G-Code Sender is just looking for G-code to be files ending in .nc. So you want to make sure that you name these files either when you were originally saving them or after the fact as .nc files. So now I can go into Universal G-Code Sender, browse for a file. I'll pick up this starting with the Pinecar-flat, open it. Then it would just be a matter of setting up your workpiece 0 to match the point that we had chosen in the software, and starting. Hit go. Alright, so I'm going to show you just some pictures. Here's a picture of setting up the fixture. Here's a picture of squaring the material on the work surface. Here's a picture of just like measuring the Z height to make sure it's accurate in the software. This is where I'm going to set X and Y 0 on the top corner, and then I'm going to set Z 0 down at the work surface. So again, there's the Z being set down there. And then we just go ahead and cut it. So once you've finished the first operation, you're going to grab the ball and mill. And then you're going to go into the software. You'll see that the Z is just at some arbitrary height after you've installed the bit. Now you're going to bring the bit back down to the work surface, make sure it's right on there, and then hit reset 0 to 0 the Z again. And then you'll just load up the second G-code file for the ball and mill,
and start cutting.